Good day, let's graph some linear inequalities. Okay, here's some linear inequalities that we're working with here. Here's three examples. We're going to be graphing these on this XY graph. And to do this, you kind of treat these the same way that you do your slope-intercept. So as you remember, slope-intercept is going to be your y equals mx plus b, where b is your y-intercept and m is your slope. So we're going to be using that same kind of strategy that you do for regular slope-intercept, your linear equations, but now we're going to be working with these linear inequalities, working with these inequality signs. So let's do this first one here. I'm going to go ahead and erase this stuff. And let's work with this first one, this y is greater than negative 3x plus 4. So here is our y-intercept. We have a positive 4. So we just kind of count up from the origin here. We're going to say 1, 2, 3, 4. Okay, there's our y-intercept. Here is our slope, negative 3x. As you remember, your slope is rise over run. So that means we're going to go down 3. Okay, down 3 and then over 1. Okay, rise over run. Negative 3 means down 3 over 1. So we have down 3, 1, 2, 3, and over 1. So here we have our second little point for our line. And we could go ahead and do that again. So we're going to go down 3 over 1. So here we have 1, 2, 3, and over 1. All right, now you want to keep in mind that when we're doing these, if your symbols are greater than or equal to or lesser than or equal to, it's going to be a straight line. If it's greater than or lesser than, it's going to be a dashed line. Okay, so here in this situation for this first one, we have a greater than or equal to sign. So we're going to have a straight line with no breaks in between. Okay, now the next thing we need to do after drawing our line is we need to know which side we're going to be shading in. We're either going to be shading in this side or we're going to be shading in this side. Okay, one side or the other of this inequality is going to be shaded in. And to kind of figure out which side we're going to shade in, what we need to do is come up with a test point. The most obvious test point, if the line's not going through it, will be the origin. So I'm going to go ahead and put this in green for the test point. Okay, our test point, okay, is going to be 0, 0, the origin. So now what we do is we take this test point, we plug it into the inequality, and see if it is true or not. Okay, we're going to see if this rings true or false. Okay, the test point 0, 0. Is it true or false to this equation, or to this linear inequality? Okay, so let's plug it in. We have y 0, 0. So 0 is greater than or equal to negative 3 times 0 plus 4. Okay, all we're doing is taking this test point. Here's our x. Plug that in for x. Here's our y. Plug it in for y. Okay, this is what we get. So now we have 0 greater than or equal to negative 3 times 0, that's 0 plus 4. So is 0 greater than or equal to 4? The answer is no. 0 is not greater than or equal to 4. So what that means is that this test point that we use, the origin 0, 0, makes this linear inequality false. Okay, so when it's false, that means that this is not the side that gets colored in. We're going to be basically shading in this side over here. Okay, because this test point is false for this linear inequality, that means that we have to shade in the other side. Kind of move this stuff out of the way. And to do that, we just shade it in. Okay, this goes on and on forever because this line just keeps going. So there it is. there's kind of how you do these. You're just going to be shading in this side. And okay, so that's the graph of the first linear inequality. That's what it looks like. All right, linear inequality number 2. Y is less than or equal to 3/5 x minus 5. Once again, -5, that's going to be our y-intercept. So we start here, we go down 5. 1, 2, 3, 4, 5. Okay, there's our y-intercept. Our slope is 3/5, so that means up 3 over 5. Okay, positive 3/5, up 3/5. So there's 1, 2, 3, up 3/5. 1, 2, 3, 4, 5. Okay, another one. 1, 2, 3. 1, 2, 3, 4, 5. Okay, there's gonna be our line along this path here. All right, now we're going to take a test point. Once again, if your line here is not going through the origin, then the origin is a very easy test point to use. So our test point, once again, is going to be 0, 0. So plugging in 0, 0 into our linear inequality, we get 0 is less than or equal to 3/5 times 0 minus 5. So we get 0 is less than or equal to 0 minus 5. 0 is less than or equal to -5. Okay, is 0 less than or equal to -5? Okay, the answer is no. 0 is greater than -5. Okay, remember on a number line, here's 0. Here's -1, -2, -3, -4, -5. Okay, here's -5. You see 0 is greater than. Anything to the right is greater than. So 0 is greater than -5. So that means that the test point 0, 0 does not make this linear inequality ring true. So once again, what we're going to do is shade in the other side. Okay, the shading goes on and on and on and on forever. So there it is. There's the graph of this second linear inequality. Kind of looks a little something like this. Okay, this is all going to be shaded in. And once again, we use a straight line here. This line is straight because it's a lesser than or equal to, this equal. So that means this graph touches the line. Okay, includes all the points that are along this line. All right. Y is greater than -x minus 5. So our y-intercept is going to be -5. So we got 1, 2, 3, 4, 5. Here's -5. Okay, -x. That just means our rise over run is down 1 over 1. Okay, down 1 over 1. So down 1 over 1. Down 1 over 1. Down 1 over 1. Okay, there's going to be our line there. Now keep in mind here that this is greater than, not greater than or equal to. So the line along here is going to be a dashed line. Okay, it looks something like that, dashed lines. So now we need to take a test point. Once again, we're going to take the test point as the origin, just because this line's not actually going through the origin, makes it an easy test point. So now we have 0 is greater than -0 minus 5. 0 is greater than -5. Is 0 greater than -5? The answer is yes, 0 is greater than -5. So in this case, we're going to be shading in everything up here, including the test point. Okay, remember the shading goes on and on and on. There's an infinite amount of shading you could do. So this test point that we used made this linear inequality ring true. So once again, 0 was greater than -5. Yes, it is. So that means we're going to be shading everything, including the test point. All right, here's one that looks rather simple. Y is greater than -4. Notice we don't have a slope. There's no mx, but we do have the b, mx plus b. We have this, which is our slope intercept. So we start off at -4. So 1, 2, 3, 4. There's a -4. Now y is greater than -4. There's no slope. So that means we're not going up 1 over 1, up 1 over 1. We're not doing this rise over run. Okay, rise over run is 0. So what that means is it's a straight line. Okay, straight line. But keep in mind that it's going to be a dashed line. Okay, what I meant by straight line is it's going to be straight horizontally. It's going to be a horizontal line. I should say a horizontal line. But it's going to be dashed. So here at -4, it's just going to be kind of a dashed line that's horizontal. Okay, if y is greater than -4, okay, greater than -4, that means it's going to be everything up here. Okay, here's all your greater than -4. Okay, simple way to think about this is if, I plug in a number for y. Let's say I plug in this number here, 1. Okay, right here, 1. Y equals 1. Okay, if I plug in y equals 1, if I plug that in, is 1 greater than -4? Yes. 1 is greater than -4. So we color in everything, including this test point, everything on this side of the horizontal dashed line. Okay, and what this dashed line means, when you have this linear inequality that's just greater than or lesser than, is that everything's going to be shaded. And it's going to get infinitely close to this line, but it's not going to include the line itself. So in other words, it's going to be, -3.999999, on and on forever, -3.9, but it's not going to actually touch the number -4. So it's going to get very, very close, very, very, very close, but not actually touching the line. Okay, it's going to get infinitely close, but it's not going to include the number -4. Okay, that's what this inequality means. Greater than. It's not greater than or equal to. If it's greater than or equal to, it would include that number -4. Okay, but in this case, greater than just means we're going to get very, 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 very close to the line. We're going to get very close to it without actually touching it. All right, what if we have something like this? X is less than or equal to -5. Okay, x is less than or equal to -5. Well, here's our x. Here's our line for x. So let's go -5. There's 1, 2, 3, 4, 5. Okay, there's -5. Okay, less than or equal to. So you notice this isn't in kind of a y equals mx plus b. So this is kind of the same as the last one I just showed you. It's just going to be, but in this case, since it's x, it's going to be a vertical line. Okay, so here's our vertical line. Okay, this just keeps going on and on. And since we have this less than or equal to, the line is going to be straight. Okay, not dashed. And then x is less than -5. So here's -5. Here's everything that's less than -5. Okay, here's everything that's greater than -5. Okay, so here's everything that's less than -5. You just kind of shade all that in. Okay, this is the side that you're shading in. Okay, and once again, since this is a less than or equal to and the line is straight, that means it gets all the way, it includes all the points that are along the line. Okay, everything that's on the line gets included. Alright, here's our next problem here. This 3x minus 2y is less than 10. So before we could graph it, we need to put it in a y-intercept form. So to do that, we basically solve for y. Okay, something to remember that when you're solving one of these linear equations, you're going to put it in y-intercept form, that if you are multiplying or dividing, okay, by -1, if you're multiplying or dividing by -1, that it switches the direction. Okay, so if you multiply or divide by -1, you're going to switch the direction. So here we have this 3x minus 2y. So the first thing we're going to do is subtract 3x from both sides. Okay, minus 3x minus 3x. So we have -2y is less than -3x plus 10. Okay, next thing we're going to do is divide by -2. We're going to divide everything by -2 to get y by itself. Okay, so divide by -2, divide by -2, divide by -2. And like I said, if you multiply or divide by a negative number, okay, this sign is going to switch directions. So let's go ahead and switch the directions of that so we don't forget. So here we have y is greater than, okay, -3 divided by -2, that's just 3/2 x. 10 divided by -2 is -5. So here we just turn this into a slope-intercept form. Okay, y is greater than 3/2 x minus 5. Okay, so to do this, we're going to go ahead and plot it out. So here's our y-intercept, -5. So that's 1, 2, 3, 4, 5. There's -5. Okay, up 3 and over 2. Up 3 and over 2. I'm going to go ahead and erase this stuff here. Up 3 and over 2. Okay, here's up 3, 1, 2, 3. Here's over 2, 1, 2. Okay, up 3, 1, 2, 3. Over 2, 1, 2. Okay, now once again, we're using a greater than. So it's going to be a dashed line. It's going to be a dashed line. All right, there's our dashed line. Now we need to use a test point. So let's use the origin. That's a very easy test point. So our test point is going to be 0, 0. So we have 0 is greater than 3/2 times 0 minus 5. So 0 greater than 0 minus 5 is 0 greater than -5. The answer is yes. 0 is greater than -5. So what that means is we're going to graph everything on this side, including the test point. Okay. Once again, with this dashed line, with this greater than or lesser than without the greater than or equal to, so it's a dashed line, that means we're going to get infinitely close to this line, but without touching it. Okay, we're going to get very, very, very close to the line, but we're not going to include any of the numbers on the line. All right, here's our last problem. X minus y is greater than 2. So once again, we need to get this in slope-intercept form, which means putting y on the left side, everything else on the right side. So to do that, we're going to subtract x from both sides. So we have -y is greater than 2 minus x. Okay, another way to write this is -y is greater than -x plus 2. Okay, 2 minus x is the exact same as minus x plus 2. Okay, this minus x plus 2 and 2 minus x are the exact same. Okay, I'm just changing the order. Okay, so next thing you need to do is divide. Here we have this negative. We divide by -1 or multiply by -1 to get rid of this negative sign. So divide by -1, divide by -1, divide by -1. So we're left with y is less than. Okay, we need to switch the directions of this sign here. Okay, remember, if you're dividing or multiplying by a negative number, that the sign switches directions. So we just switch the direction of the sign. And negative x divided by -1 just gives us a positive x. 2 divided by -1 gives us -2. Okay, so here is our slope-intercept form of this linear inequality. So I'm going to go ahead and erase all this stuff above it. And this is what we'll be graphing. Okay, so our y-intercept is -2. So there's 1, 2. Here's -2. And our slope is x. So that just means up 1 over 1. Okay, remember there's an invisible 1 out in front. So that means up 1 over 1. So up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Okay, here's our line. Now what we want to do is fill in this line. Remember that it's going to be a dashed line because our inequality is lesser than, so it's a dashed line. Okay, it just looks something like this, just a dashed line. Okay, now we need to take a test point. Let's take the origin. So there's our test point. Test point is 0, 0. So we plug in 0, 0 into this linear inequality. We have 0 is less than 0 minus 2. So 0 less than -2. Is 0 less than -2? The answer is no. 0 is greater than -2. So that means we're going to shade in everything opposite of the test point. Okay, and there it is. There's our last linear inequality all graphed out. Okay, quick lesson on linear inequalities. Just to reiterate that if you have a less than or greater than, okay, it's going to be a dashed line. If you have less than or equal to, or greater than or equal to, it's going to be a solid line. Okay, the other tip is that when you multiply or divide by a negative number, okay, let's say -1, multiply or divide by a negative number, that it switches the directions. Okay? Switches the direction of these inequalities. Okay, either one, either these one or these ones. Same thing. Switches directions. Okay, if you like these type of videos, please press the like button, leave a comment down below. If you want to see more, simply subscribe to my channel for more videos. I want to thank you for watching and wish you good luck in your studies. Thank you.